Hello, welcome to Basic Chemistry's 4th SAT Chemistry video, and in this video we're going to cover Part C, question 40 to question 63 in the 1998 SAT Chemistry exam. Let's start with the first question. What volume of a 0.5 molar solution of hydrochloric acid, is required to neutralize 0.6 milliliters of a 1.5 molar potassium hydroxide solution? 1.5 m, 0.6 liters, because 60 milliliters is 0.6 liters, right? And the volume of HCl is unknown, so it says the x liters, right? Let's first write the neutralization reaction formula, or the equation rather, for this acid and base. So HCl plus KOH turns into KCl plus H2O. You don't need to balance anything, it's already balanced. And so this is the formula. And basically we know that acid plus base turns into water plus their corresponding salt. And here we know that acid is HCl, base is KOH, their salt is potassium chloride, and water is H2O. So because the coefficients are already balanced, so we know that in every 1 mole of HCl, we need 1 mole of KOH to neutralize it. So basically we can use the formula of M1V1 equals to M2V2, right? So what would the M be for the HCl side? So this will be the HCl side, and this will be the KOH side, okay? So what would be the molar of HCl? Well, it's already given, right? It's 0.5. So it's 0.5 times X volume, or rather X liters, because the volume of HCl is unknown, right? As you can see here, it's unknown. That equals to 1.5 m times 0.06 liters. And this value is from here, right? Now you can know they're the same. The 1.5 here moves here, and the 0.06 moves here, because this is the volume and this is the molar. Alright, so let's do this. 1.5 times 0.06. So the answer for this is 0.5x equals to 0.09. So if you want to find this x, or rather the volume of HCl, you just need to divide both sides by 0.5. So x equals to 0.18. Remember, this 0.18 is in liters. So basically it's 180 milliliters, right? So the answer would be B. According to the equation for the reaction represented above, what is the mole ratio of CO2 that is produced by the decomposition reaction of aluminum oxalate? Now, in this question, we need to first balance the chemical equation, right? So basically, let's try to balance it first. There's already 2 aluminum here, so let's try put 1 here. It might not work, but let's try first. And then, because there are 6 carbons, right? There's 6 carbons if you just multiply C2 by 3. So let's just try put 3 and 3 here and see if it works, right? And there are here 12 O's. So here we have 3 O's, and here we have 6 O's, and here we have 3 O's. So 3 plus 3 is 6, and 6 plus 6 is 12. So we know that it satisfies the 12 O's in the reactant side, right? So we know that the answer should be 1 mole of CO to 1 mole of CO2. Number 42. When the equation for the reaction represented above is balanced and all coefficients are reduced to the lowest whole numbers, the coefficient of B2H6 is... So this is basically just balancing chemical formulas. Now we can see that because there's B2H6 here, we need to put a 2 here. But now we see that there are H6 here, but there's just H4 here, right? And there are no more H's here. So we know that lithium aluminum hydride is present in more than 1 moles. So we know that 2 is not supposed to be there, right? So let's try to find the lowest common multiple of 4 and 6. And we would instantly know that it's 12. So let's put a 3 there. And let's put a 2 there. And now we have 4 B2s, I mean rather 4 borons, because it's 2 B2s, so we could put a 4 there. And when we do that, we have 3 lithiums, so we need to put 3 there. And we have 3 aluminums, and we have to put 3 there. So we have 3 Cls, and here we have 9 Cl. And we know that it satisfies the 12 Cl in the reactant side, so the answer should be 2.
And he became one.
Now let's move on to number 43.
Member,
According to the reaction for the equation represented above, which of the following statement is true?
So my
Let's see.
is a member of
If 2 moles of aluminum are used, 1 mole of iron is produced.